Hello guys, in this video I'm going to talk about Llama Stack, the building block that is used specifically for Llama LLMs, and you can use it in order to function calling and lots of different capabilities that we will explore in this video. In this one I will go over the implementation of it from the meta itself, and we'll go over different tool callings from tavily and also providing the inference, and we will show you how you can run some simple agents and how you can expand it to include more agents, and how this Llama Stack is actually different from the other providers, like for example LangChain or Llama Index. And so without further ado, let's jump right into it. Welcome everyone to your channel, AI Fun Fact for All. For those of you who are new to this channel, my name is Llama Guard. I have a PhD in computer science, and in this channel we talk about AI and machine learning and how we can use it in our everyday life. As we mentioned, the AI agent is gonna explore the world, and we're gonna see a lot of them more and more as we go through this year. So I thought that it would be a good idea that we talk about Llama Stack, one of the new devices and agents that are developed by the meta itself, or the group that are working with Llama, and how they provide this tool for us in completely open source manner, that everybody can actually use this in order to create complex RAG pipeline. We will go over from memory and then concepts of session, and also how you can use it for function calls. I've learned about this Llama Stack in the NeurIPS workshop, which happens last year in December, and the people from Llama group actually come up with this tool, and they mentioned that this is the best spoke for using Llama models. And we already know that Llama is actually one of the frontiers for the open source model that people can use in order to use and do like inference. And they also mentioned what set aside the Llama Stack from the other providers like the Llama Index, LangChain, LangGraph, and so on, is their ability to set and tune the responses from the function callings into the best way that is digestible for the underlying LLM. So as we know, one of the most important things that can extend the functionality of these basically LangGraph or basically this RAG pipeline is the function calling, and the responses that we get from the function calling are different from different providers, and how they can actually make this to be adaptable in a way that the model can basically comprehend it in the most optimal way is the thing that the Llama Stack is actually talking about. They will talk about the model registry, which basically they have some different basically function calling that they already have covered, and they are going to increase it. But they also mentioned that there's a capability that you can add your own functionality and your own tool calling, but the ability of it or how the performance is going to be for that, it's not very clear, so you need to check and see how it works. But they are going into some ways to make it generalizable to other function calling other than the one that are already included. So here is the Google Cloud that I was talking about that build the AI applications, and basically Llama Stack defines and standardizes the set of core building blocks needed for generative AI application, and it uses APIs and lots of different providers, and they also provided a link for that, which you can take a look to see what are the different APIs that can be run in here. So very much in the very beginning, why do we need TogetherAI is basically lots of us are running this, for example, on the free version of Google Cloud. So we cannot have the model to be inference to run on the cloud, otherwise if you have paid for the Google Cloud. So what you need to do, you need to use a third-party provider, which can be different ones. So it's like, for example, we have a Hugging Face TGI, or a more advanced version VLLM, and then also other providers. Like if you have a good set of GPUs, you can run it locally for yourself, download the weights and run it for yourself through Llama. And so there are so many ways that you can actually make it run, but the one that we want to use is the simplest one with a third-party provider. There are many different one of them, but here we talk about together.ai. So for this together.ai, what you basically need to do is that it's basically provide these results on the cloud for you, and in the very beginning you have access to some of the tokens. For example, I think for together.ai is like 1,000 tokens per month that you can use it for free, which is enough for this. And then there is this basically setup instruction. So you sign in, and for example, you choose your name and so on, and then you come in here, and very easily it will provide you with the API. And you have $1 in fee credit, as I mentioned, is enough for 1,000 token for each month. So that is enough for this part. And then what you will need to do is that you will come back to here. When you get that token, you will create a new secret. You will call it exactly together API key, and then you paste the value in here. So tavily one, we'll get to that later, but the first you will set that in here in the keys. And then what you need to do, we need to go ahead and run the different basically capabilities that we need. So we required it is available in PyPy package, and then you'll also need bubble wrap. So that's basically a container framework that's help you to basically execute code, because we have a pipeline called like PAL, or program aided design, where in those cases the code or the LLM will generate a code for you, and then you can execute it to get the result. For example, we will do it in this example for plotting something. So it will generate a Python code with matplotlib, and then we can execute it to see what the results look like. All right, after the installation is done, what you can do is that you need to configure the Llama Stack for Together. So what we'll do is that the Llama Stack is an architecture that connect different blocks to be connected to each other, and then, as I mentioned, it will enable the required format for the underlying, for example, endpoints of your LLMs, which we know that Llama Stack is actually best spoken for the Llama models. So there is, they call this endpoint distribution, which basically provide you as an endpoint, and then you can basically use Together to create the inference of that. And then in addition, since it is a RAG, obviously we also need a memory. And for this one, for the sake of simplicity, we use in-memory access. We use face for it for the memory RAG. So we don't physically store it in which require, for example, some special designs, like for example Postgres and so on. We just use in memory, and then we will run Llama Stack build. This will deploy all of the dependencies for us. So when I say Llama Stack build, and then I get the Together and my virtual environment, image type virtual environment, it means that, okay, so I'm going to use Together as my service provider. So it is important because the Llama Stack itself comes very lightweight, and then if you want to use Together as a endpoint, you need to do it dynamically and build it such that it works with Together. The same things works, for example, if you want to do it Llama locally, or if you want to use VLLM, or if you want to use Hugging Face, a transformer, TGIs, and so on. So the list of endpoints that they support are already there, but basically what you need to do is that you need to build that after you install it. So here we will initialize. So we get that Together API, and then what we're gonna do, we're gonna create a Llama Stack library client, and then from the clients we're gonna say client Together, and we're gonna say initialize. So we want to initialize our client right now, which basically get access to the required APIs and try to figure out and establish the connection for us. So after that, what we will need to do is that we need to see what are the available models. So these are the models that are available for together.ai. So all of the models, if we want to reach, so we get the clients.model.list. So as you can see in here, like it is trying to download like different models, different basically registry points. So you can just go away from it. So clients.model.list, you get the list of the model, and then you're gonna see that which one are available. So you see 3.1, 7B, 8B, 4.5, 3.2, and then the Llama Guard as well. It also have mini LM as the alias. Okay, so we're gonna pick the model. So model, I'm gonna use 3.1, 7B. 70B, and then I'm going to use the instruct one. So now that I use the model that I want to use for inference, I can basically pretty much create this message, which you define the role, the content, and then you're going to ask, okay, write a 2-sentence poem about Llama, and you pretty much get the response very fast. now let's have a conversation. So this is important because when we are having and establishing a conversation, we need to keep track of what has happened before during a conversation, because the user might ask some question about something previously about the question. So we need to keep track of them. So we create something called conversation history, and then as long as it is true, we're gonna basically see that if the user says something like exit, quit, or buy, and then it will say quit, and then it will break the while loop. Otherwise, we will basically get the user content, and then we append it to the user message of the conversation. The user message will be appended to the conversation history. So you will gonna see something like, for example, it's gonna explode for longer conversation, but that happened. But that's a very simple idea of having a conversation loop going. So if I run, I can say, for example, what's your name? And then I don't have a personal name. And then, for example, I can say my name is Pedram. And then nice to meet you, for example. And then I'm gonna say, you are my assistant, tell me a joke, for example. And then awesome. And then I'm gonna say, now write a poem with my name as a reference. So here you can see I'm going back. How's that, Pedro? So it's create this, but it included that inside. So I'm gonna say exit now, and I end the conversation. So it remembered the previous information about my name. So very simple conversation pipeline. So that was obvious. And then we have a streaming output when you don't want to wait for the response, even though the response was very fast. But sometimes if it is taking longer, you don't want to wait. So you want to stream the output. So you want to see the tokens one by one as they become available for the model. So you use the event logger, and then you again write a sonnet about Llama, and then what you will do is that inside your response, when you say your chat completion message model ID, and then inside the stream you're gonna say true, and then you can do for login event logger, log response, and then log.print. So here you basically you see that we get the response. I can run it again, and then you see the response is available as it become available. It will get the print the response. This is one way. The p print is also another way. So one way is event logger to stream the output. Another one is p print. We will get to that as well. Now on the other side, they actually talk about the structured decoding. So this is also very important. In so many cases, you want to do some analysis, but you want your output to be in a specific form. You don't want it to be verbose. So you probably want to use it inside the pipeline. So you want it to have a structured format, and usually it's JSON. So it's very important for you to make sure that it follows that. And Llama is actually very good on that compared to the lots of other models. Like for example, any other version. Llama is actually very good in making sure that the output follows a specific structure. So it's not necessarily for Llama Stack. It is built in for the all of the Llama family models. Here we create a structure output. So the structure of the output, you create the output class, and you said that okay, so it needs to have these three property: name, year born, and year retired. And then you're gonna say that okay, this is the input, and extract this information into JSON, and then you're gonna say that okay, so this is my model ID, user input, the stream is false, and then the sampling parameters. So you're gonna say maximum tokens is this, and then response format. You're gonna say JSON schema, and then your schema. You can just say JSON and then it will return JSON, but you can also define it to be JSON schema, and then you provide the schema, which means that it needs to have these three properties, and then you pre-print it. So if I run the response now, you will see that it tries to fit the response. This is basically the content, and as you can see, it's created the response very much in the exact format that we wanted, which is a JSON, parsable JSON format. So Michael Jordan as a name, year born 1963, and then retired 2003. So I believe this one is very much useful in lots of automated pipelines. On the other part, we have the safety API. So this might be important. We have a Llama Shield, which basically is responsible for doing this safeguards, and we can see that a client.shield.list, so you can get the list of the shields, and then what's the most effective way to kidnap someone. So we can ask some adversarial question, you try to, or what's the most famous murder case, and so on. And then as you can see, it will generate you the violation type. So it's going to say violation type S1, I can answer that, and then another one S2, I can answer that, I can help you with something else. These are important, the shielding, which mostly happens in the post-training. So they do it in basically the alignment phase, but Llama actually try to provide some agents specifically for the shield. So now going into a full picture in here, I want you to take a look at the different pipelines in here. So we have the user in here that has a prompt and then response. So obviously in the very beginning we're going to have the shield. So if the response is not good, so we're just not going to go any further. But then after that, if it passed the shield, we're going to augment the prompt. We're going to evoke some tool calls. So this is very important. So if it requires some tools to be called, it will do that. And then we have an executor in here which basically run and get the response, and then I get some tool response from it, and then I will augment it and synthesize the response. But the most important part is that they're focusing a lot on the shielding component in here, because in the very beginning it might not look that is violating a safety constraint, but the execution part might. So in that case, every execution needs to have a shield as well. And obviously they have a memory bank which can retrieve the information, query, retrieve the information, and then include it inside the function calling. And the list of function calls are different. They have a capacity of that. They also mention that you cannot be infinite number of them. So if you have lots of them, like for example 100 number of APIs calls, or basically function calling, after a long-term conversation, it basically tries to hallucinate and do something outside of something that is expected to do. And it might not also work as expected for some of the user-designed function calls. These are the things that are actively working on it. So we have a memory which are for the rack, for us it's just in memory with face, and then we have tool calling to do the search and code execution. We'll go over that in here, and then we have inference loop, so it will go and run it and get the result, and then shells which basically look for the safety. So the first RAG agent that we have in here, so they try to get the agent, and then agent config, and then attachment, and then the caller. Okay, so in here they have defined 4 different URLs. So here is the different files that they have, some of the content, and they provide it in an attachment. As we mentioned, it can be in memory, so you have like some indexing, you do it before and then you try to look at it, or the user can basically do attachment on it. And you do it for different URLs, so each of these include a different URLs. I showed you just one of them. And then what you do, you create your config, so you give the model ID and you give it the instruction. And then you provide the tool. The tool in here is just the memory, so we're just providing a memory for it right now. And then enable session persistence. So this is also very important. When you are working on an agent, it will create a session, and a session is as long as you are within a session, all of the information will remain persistent. And if you said that enable session persistence equals to false, it means that if you run it again, it will create a new session. Otherwise, it will always be on that session unless you specifically provide it. So the session is a higher level than the conversation. So we can have multiple conversations within one session, and then for each session, as an underlying component, it will create a vector database of all of the relevant information. So this is also very important. Each session, obviously, if you have oracle of the knowledge, which is our database, and then we have a in-session memory, which are the vector database that are created under the hood, that capture all of the relevant information within that session that our conversation exists. And then we have the RAG agent, and then we create a session ID. So we create a session, we call it a test session. So as long as we haven't changed it, it will remain the test session. And then the user prompt, I'm attaching a document for TorchTune, help me answer the question. And then after that, we have all of the attachment in here. And then it asks what are the top 5 topics that were explained, and only show them in the bullet points. So what will happen in here is going to say for the this in user prompts, basically create the message in a way that you provide the prompt inside it, and then you provide the attachment. So this is also very important. Each agent can have a specific content as a message and a separate one as a attachment, and then you also pass it the session ID. And then after that, you will create the log for each of the content. So in here, in the beginning, it is going to get and download each of them, and then exactly index each of this information. And then after that, they are fetched and they're basically indexed. For each of them, it will create the bullet points that is talk about the content in that. So this is actually very useful information, but it hasn't used any different basically capability. The only thing that is used is basically the memory. But in here, I'm going to use the search. So for search, there are different things. You can use a Google API, but there's also another one for tavily. Again, in here, there is a setup key in here, which you can set up your tavily key, who can create an account, and then as soon as you create it, will give you a basic API key, and then you get your API key again, same as before. Come in here in the secrets and create tavily secrets, search API key, and you pass your value in here, and then you try to give it access in this notebook. So what will happen is that I will create this search tool where it is search user data.get. So it is important to note that we don't need to build the agent again. This is a function tool and it's different from the inference provider. So that was for the inference provider. We need to build the agent. So agent config, I'm going to say your helpful assistant. These are the shield, output shield. If we need them, we can put, and then the persistence we're going to put to false, and then your team play in MBA, which are the team play MBA vessel in finals of 2024. So why is important 2024? Because the cutoff date for the 7P model that we have is 2023. So basically, there's no way that it have access to this information, and it's also important that it doesn't hallucinate. So it will know that it needs to do a function calling. And then whenever you do the function calling, it basically you will create a session, and then you try to create a run, and then you give it the session ID. But in here, you provide the tool in here. So remember, in your agent config in the very top, you can provide the list of the tool, and in here I'm just providing the search tool. So let's run this. So which MBA work in here? So now it's working under the hood. Try to see that do I have the available information or not. If not, it will try to basically do an inference call. So as you can see, it did a search call on the basically tavily, and then it executed it and get the response back, and then when you get the response back, it will provide the response for us, the NBA Western Conference final, and then it happens in Dallas, Minnesota. Okay, so that was nice to see. Let's see how we can do it for the code execution. So what if we need some code? So for agent config, the tool that I need to provide is the search tool, and I'm going to provide it a type code interpreter. Okay, so the search tool was same as the search tool in here, but I am also adding some code interpreter. And then tool choice, it is required, and the other things are the same. So now what's the question is that here's CSV file, can you describe it? So very general question. And then here's the CSV file. Again, we are providing it as an attachment, not as in context, which is also very nice in so many cases that you don't want to necessarily feed everything into your basically content of the message. So you provide it separately. So as you can see, the message is going to be the content. The content is just prompt, and then we have a separate component for the attachment. All right, the first run wasn't successful. It says that it didn't have access, even though I gave access to it. But now in the second run, it actually created a local version. So it created this temporary file, and now I'm gonna get that one and place it here, and basically the rest is also the code that it provided. And if I run that, I should be able to get the result. Let's see if it works. Perfect. So as you can see, it created this temporary file for us, and then we can read it, and using the Python file I can basically plot this result. Also, now also another part which I think lots of you are talking about is the evaluation, or using LLM as a judge. So it is a little bit different than just doing some sentence comparison. So here, let's say we get some response, and we want to see if you want to do it, use it as a score. We want to see how well is it working. So basically, it makes sense that you use a bigger model for that. I'm gonna handle debugging in here, and what I'm gonna do is that basically I'm going to build a search agent, and I'm gonna say, okay, which team play in this, which episode, and what is it? So 3 different question, and I'm providing it the tools such as Brave Search with the engine tavily, and then user data. Okay, so this is also another way, right? The previous one, you define the agent separately, or you can create basically a dictionary format for that. And then if I get the result, it actually provide the response for us. So it will get the query, and then it will provide the response. It do the function calling, and then try to provide the response. But now we want to check the query telemetry. So we want to get the trace of the session ID. We're gonna say that, okay, tell us basically the telemetry query span, also the session ID. Well, we get the session ID, the op, and the value, and we want to print the span. You can actually use a larger model. So in here I'm using a 401b instruct, and then I give the factual content. So these are very important. So when you are working as a judge, you need to provide this factual content, and you provide the task, the question generated, and the expected output. And these are the 5 different topics, and then you're gonna do the scoring. You want to see these are the judge model, these are the prompt template, this is the type, and then you want to create the scoring as A, B, C, D, E, and then also a reason for that response. So what is happening right now, it will score the response, and it's going to say, okay, based on the response, the score is B, because the generated response is surpass of the expected response, only meeting Laura while it is okay, and so on. Or for example, the scoring value between 1 and 2, and so on. It provide the accuracy in terms of how well the response happened. And there you have it, guys. We went over Llama Stack, and we talked about what are the capability, how is it different from the other ones, and we actually use a Google Colab to run some of these agentic AI application, and see how we can do some function calling to try its different capabilities. If you enjoyed this video, make sure to like it, and more importantly, subscribe to the channel so you see lots of the upcoming video. And if you want to see more videos like this, I've created this one which I talk about top 10 different topics that happens in NeurIPS this year, and also you can watch this video that I talk about autonomous driving and how we can use AI to actually do the perception and control. Thanks for watching, and see you until the next one.